So for this question here, we are going to look at factorizing cubic polynomials. For this particular expression here, notice that there is no definition or function definition. So what we're going to do first is let this equal to a particular function. I'm going to let it equal to p of x because the capital P there will stand for a polynomial. Once we do that, we need to substitute a particular x value into this question here, into this expression, in order to make all the terms, when we group them together, equal to 0. This follows the remainder theorem, since if the substitution of the value is equal to 0, then the remainder is equal to 0, which means that it's a factor. So usually first you'd try 1 and -1, but we get those numbers by looking at this final number here, which is 6, and we want to try factors up to 6. So factors that you can try to substitute is -1, 1, -2, 2, -3, 3, -6, and 6. These are all factors of that 6 there. So let's start off with the easy numbers, and that's why we want to use that. We'll start off with -1. It's either going to be -1 or +1, so it's trial and error, but with time and experience, what you can do is you can substitute this simply in your head and evaluate them there. -1 x cubed minus 2 times -1 to the power 2 minus 5 times -1 plus that 6 there. So just evaluating these here. We can see here now, the idea here is that you group the negatives and the positives. If you can clearly see that they do not equal to 0, then you can just simply say it does not equal to 0. So if -1 does not work, this means we should try +1. So let's try that again. 1 cubed minus 2 times 1 to the power 2 minus 5 times 1 plus 6. This is equal to 1 minus 2 minus 5 plus 6. So the idea is to group the positives and the negatives. This here makes a +7, whereas the negatives makes a -7. So yes, this does therefore equal to 0. Once we know that this equals to 0, we can therefore say that this x value that we substituted in is equal to 1. And in order to turn this into a factor, we take the 1 to the other side of the equation. So it becomes x minus 1, and we equate that to 0. This here is a factor of our expression here, or our equation here, of p of x. So we're saying that x minus 1 is a factor. Since it has no remainder, since the remainder here is 0. So by the remainder factor theorem, the remainder is equal to 0. So then, once we have x minus 1 is a factor, then what you can do is you can do long division or synthetic division in order to break this cubic up into a linear. Here's one of our linear factors, and a quadratic. So I'll do this here on the right hand side. So when it comes to synthetic division, I'll do synthetic division here because it seems like it's favored for more simple questions. We need to set it up. We've got the 1 on the outside, that's what this x equals 1 is there for. And then each of these terms of our cubic expression will be placed here using the coefficients. If you haven't had a chance to learn synthetic division yet, please go look it up or watch one of the previous videos. I'm just going to write const there for constant. Now the algorithm goes is that you drop the 1 down. You drop the 1 down. I'll use green here for the quotient. And in order to get your next section, you multiply by the divisor here. So multiply by 1. You end up getting 1 times 1 is 1. And then you add vertically to obtain the next quotient. So -2 plus 1 is -1. Multiply diagonally by our divisor, which is 1. -1 times 1 is -1. Continue the algorithm, add. Our next quotient here is -5 plus a -1, which is -6. Cross multiply here with the divisor. This obtains -6. And then we add again. Finally, our final number here is our remainder, which is 0, and this matches up here with our remainder theorem, showing that it is a factor. So these are our coefficients of each of our terms now. The power of each term reduces by 1. Therefore, our p of x here of x cubed minus 2x squared minus 5x plus 6 can be split up into these factors here. So we've got our linear factor, which is x minus 1. That's the same factor here. And this quadratic expression here. Okay, so we've got x minus 1 at the front. And then we also have x squared minus x minus 6. That section is this here. Okay. Now, we want to break this up as into its smallest constituents as possible. That meaning 3 linear factors. So this section here can be broken up further by doing quadratic factorization. Here I'm going to use the cross method. I'm going to choose 3 and 2 for our factors. When we cross multiply them and add them together, it needs to equal to -x, so I'm going to pop it on this -3 here. If I cross multiply, that equals to -3x. If I cross multiply here, we have 2x. If we add these two sections together, it equals to -x, which checks out with our middle term there. The way we read our brackets then, therefore, is across. Okay, we read them horizontally. So we have the factors now. Now you don't have to use the cross method there. If you have any other particular factorization method for quadratics that you prefer, then you may do so. So just looking back at here, section 1, find the first factor by substitution. Yes, there might be trial and error. Okay. Notice here we tried 2 combinations. We got our factor on our second combination. Once you've got your factor, you may either use long division or synthetic division in order to find your quadratic factor. Then we write both of the linear factor and our quadratic factors down, and we split it up further. And that's how you do factorization of cubic polynomials.